All right, number 4, it wants us to find all the zeros, write the answer in exact form. So here it's going to walk us through the process that we've been using. We're going to take that constant term. We're going to put the factors of 3, which are 1 and 3. It's a prime number. On the bottom, we're going to put the factors of 11. 1 and 11 is also prime. So we only get those 2 numbers. Please check your commas. So let me see. Oh, I don't need to put both numbers yet. It just says factors of 3 and factors of 11. So I don't need to do that part yet. Okay. Then it writes the factors. It's going to divide all of them, positive and negative. And then it says next we're going to use synthetic division and the remainder theorem. If any of the numbers in the list is 0 of p, the remainder will be 0. So once we go through the process, if we get 0, and it says therefore 1 is, and we're going to fill in the blank, is or is not. So they want us to actually do it with the number 1. So I'm going to put 1 here. I'm going to list my coefficients. So x to the third, second, first. Okay, so we have all our terms. 11, negative 1, negative 33, and positive 3. Bring down 11. 1 times 11, get 11. Subtract, we get 10. 1 times 10, subtract, we get negative 23. 1 times negative 23, subtract, we get a negative 20. So because this does not end in 0, 1 is not a 0. Negative 1, negative 33, positive 3. Oh, it says the remainder. The remainder we got is negative 20. Sorry. The remainder is negative 20, therefore 1 is not a 0. I was thinking it was asking the property of being a 0. Okay, so now we're going to do the same thing with negative 1. So it says if you use negative 1, bring down the 11, negative 1 times 11, negative 11, and negative 12, negative 1 times negative 12, positive 12, subtract, and we get negative 21. Negative times a negative is a positive 21, and we get 24. So that also does not end with 0. The remainder is 24. 24 is not 0, therefore negative 1 is not a 0. We're going to do it with 1 over 11. Negative 1, negative 33, and 3. So basically when you have a fraction, you're going to divide by 11, which gives us 1 times 1 is 1, and we get 0. Divide by anything, well, anything divided by 0, sorry, 0 divided by any number is 0, times 0 will give us 0, negative 33, and then divide by 11 will give us a negative 3 times 1, negative 3, and we get 0. Okay, so this time we do get a remainder of 0, and that means that this is a 0. And then it says by the factor theorem, since 1 divided by 11 equals 0, then x minus 11 is a factor. And it says the quotient is, so the remaining, so we started with an x to the third, so I want you to write the remainder, x to the third. We reduced that by 1 degree, so this will be 11x squared, 0x minus 33, so our quotient is 11x squared minus 33. That's going to be 11x squared minus 33. And now it says if we multiply the polynomial back together, we can find the zeros of px are 1 over 11 along with the roots of this function. It says there's no guesswork because the equation can be solved with the square root property. So they're just walking us through. So they add the 33 across, divide by 11, we get this square x squared equals 3. You take the square root of both sides and you get positive or negative square root of 3. So here's what we're doing. We take the remaining polynomial, set it equal to 0. This is 33, sorry. Add 33. Divide by 11. Take the square root, plus or minus, and we get x equal positive or negative square root of 3. Okay, so this gives us our other two roots. Remember, our degree tells us the maximum number of zeros, which is 3 in this case. So therefore, our zeros are 1 divided by 11, positive square root of 3, and negative square root of 3.